Now let's talk about how to read function notation. You're familiar with equations that are written in the form y equals x squared. In function notation, we replace y with function notation f of x. So f of x and y are synonymous. And we'll talk about why would we bother to put a more complicated expression in for y when we could just use y. So we've got y equals f of x. So if y equals x squared and f of x equals x squared, we could also say that y equals f of x because they're the same number or the same quantity. And when we write it this way, we say y is a function of x. Y is a function of x. So y, x squared, and f of x in this case are all equal to each other. X squared tells us how to calculate what the y value is for a given x value. So let's look at another function. F of x equals 2x plus 3. So let's break this down a little. F is not a variable, it's the name of the function. And I have a little note over to the side here. Note, f is not a variable. And we read this f of x. F of x does not mean f times x. So I'm going to write there, we say f of x. F of x does not mean f times x. X, whatever's inside the parentheses, this is the input value. So whatever is in the parentheses is input into the function, and it replaces the x anywhere in the equation of the function. So the equation of the function, or the function rule, might have more than one x in it. But whatever that input is, now, do we always have to use x? No, sometimes we use t, sometimes other letters are used. But whatever's in that parenthesis, whatever letter is in that parenthesis represents the input value, and it replaces that same letter, that same variable, anywhere else in the rule. So let's say that x equals 2. Okay, so we would write f of 2, the input value, x equals 2. It will replace x anywhere in the function. So we would say 2 times 2, okay, so this is where the x was. It was in here and it was right here. 2 times 2 plus 3, which is 7. So we say f of 2 equals 7. When you see that notation, that means x equals 2 and y equals 7. It also means the point 27 would be on the graph. Now think of this as a function as a little box. Okay, so here once again, this is the name of the function f. Inside the box is something that we're going to do, a rule. This is our rule. So I didn't write down this as the function rule. So the function rule is this. And we see here as our function rule. We see our input. So let's say we put x equals 2 into the box. So we drop that in. Think of this as like a little machine. It takes whatever we drop into this box, it multiplies it by 2 and adds 3, and then it spits out the output, which in this case would be 7. So think of a function as a little box that has a rule in it, and we put something in and we get something out. And no matter what, whenever we put something in, it's only possible to get one unique value out, or else it's not a function. Now let's look at, we've looked at how we can evaluate a function using an equation. How can we evaluate a function using a graph? So let's say this function depicted in this graph is the function g of x. And I don't have an equation for this. As a matter of fact, there is no simple equation for this graph. Later on we'll talk about something called a piecewise function. We'd have to write a piecewise function for this. It would have lots of different equations put together for the different sections of the graph. But let's just look at it. It is a function because if we look at any x value on the graph, it only corresponds to one point on the graph, one y value. So it is a function. And we're going to use our function notation to evaluate certain things. So we see g of 3. So when you see g of 3, remember what's in parentheses is the input value. The input value is the x value on the graph. So when I see g of 3, I look for 3 on the x-axis. And then I go up or down, find the point on the graph that corresponds to that, and that is the point 3, 1. So when x is 3, y is 1, so g of 3 equals 1. Now let's go to negative 4. See if you can do it. Pause it and come back. G of negative 4 is this x value right here. We go find the corresponding point on the graph. That's the point negative 4, negative 1. So g of negative 4 is negative 1. So that's how you read function notation. Now I'm going to ask a slightly different question. It says mark where g of x equals 0 on the graph. Notice on this one, 0 is not the input value. X is the input value and 0 is the output value. So I'm saying, what values of x give me 0 as an output value? In other words, for which x values does y equal 0? That's what I'm asking for number 2. So if you look on the graph, where does y equal 0? Well, it equals 0 here, and here, and here, and here. So there are 4 different x values where y equals 0. There's 4 places on the graph. And I didn't ask you specifically what those x values were. You'd have to estimate some of those numbers. There's only one that lands exactly. We see 2 is one of those values, possibly 3.5. These 2 are kind of in between numbers. We're not sure what those are. What does g of negative 1 equals 3 mean? Can you put that into words? If I asked you to write a sentence or explain verbally what that means, could you explain what that means? So negative 1 is the input value, 3 is the output value. So if x is 1, or negative 1, sorry, y is 3, that's this point on the graph. Negative 1, 3. So what does that tell me? I could explain it one of 2 ways. I could say when x equals negative 1, y equals 3. Or I could say negative 1, 3 is a point on the graph. 3 is a point on the graph. Next question. Mark the section of the graph where g of x is less than negative 1. Okay, so let's once again think. When I see the number negative 1, am I thinking, is that an input value? Does that refer to x? Or is that an output value? Does that refer to y? Remember, the input value is right here. It's unknown here. The output value is negative 1. So I'm saying g of x is the same as the output value or the y value. So I'm saying where y is less than negative 1. So when I look at the graph, I see the place I see where y is negative 1, and I see some places where y equals negative 1, and this whole section of the graph, y equals negative 1. But is there any place on the graph where y is less than negative 1? No, because that's the very lowest part of the graph. There isn't anything below negative 1. So there is no place where y is less than negative 1. I could find some places where y equals negative 1, but not where y is less than negative 1. So, trick question on that one. True or false, g of negative 1 is less than g of 1. Okay, so negative 1 and 1, are those input values or output values? If they're input values, they refer to x. If they're output, they refer to y. Well, inside the parentheses are the input values. So I'm talking about the y value where x equals negative 1 and the y value where x equals 1. So I'm going to find those on the graph. As a matter of fact, they're both already marked. No, actually one's already marked. G of negative 1 is equal to 3 because when x is negative 1, y is equal to 3. G of 1 is right here, is negative 1. So is this true or false? This is false because 3 is not less than negative 1. Now it's important that you evaluate both of them and that you then make the connection why false, because this is not a true statement. So this is how you use function notation to read values off of a graph. You will sometimes find questions like this on standardized tests like the SAT. So this is a kind of a good skill to know. It's also very useful for those of you going on to calculus or other upper level math courses.